So tutorial sheet number 6, question 3. Question 3, we are required to find the exact values of the following. So find the exact values of tan. Let's move to 10, 240 degrees. So tan 240 degrees. So the best that we can do for this part here is to express this to its corresponding acute angle. So express 240 degrees to its corresponding reference acute angle. So if you have 240, 240 is actually in the third quadrant. So that is 270 degrees and that's 360 degrees. So you always start moving from 0 and you move in an anti-clockwise. So that is 180, meaning that 240 is going to be somewhere here. That's 240 degrees. So this 240 degrees that we have here is equals to, if you can just find, you have this part which is here. Sorry, am I So I was saying this tan 240 here, you can express it to its, you can express 240 to its corresponding reflex acute angle. So now the reflex acute angle, maybe let me just open a blank, let me open a blank page so to see what is happening. When you have this part which is here, you have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So the acute angle that we are talking about is in the first quadrant. You establish a line from here, and you can drop down this part here. This angle here is the acute angle that I'm referring to. So if you can know this angle here, this is your acute angle. Secondly, in the second quadrant, the acute angle that I'm referring to, it's always starting from the x-axis up to the line. So that is the acute angle. So if, for example, you have 140 degrees, like that. So 140 degrees is going to be equals to this acute angle here. So if you have sine 120 degrees, instead of using 100 and from this point to that point, just use the acute, the reference angle here. So if this is from here to there is 180, meaning that this acute angle is going to be 60 degrees. So this is going to be sine 60 degrees, like that. Similarly, if at all you are dealing with, you are in the third quadrant like that, the acute angle, you always move from the line, the x-axis up to where to cut that. That is your acute. That is the acute angle there. So the angle that we have now is 240 degrees. So the angle that we have is 240 degrees. So 240 is simply from this point to that point is 180. So you add another value there. So this entire part here is theta and it's 240 degrees. So the acute angle is simply this angle from the y up to this line. That is the acute angle. So if you can know this acute angle here, it's as good as replacing it where there is 240 degrees. So tan here, this acute angle, this line here is a straight line, and we not say all straight lines adds up to 180. So from this point to there is 180. Now, to find this acute angle, just say 240 minus 180, which is going to be 60 degrees like that. That is for tan. But if the same was the case for sine, the story could have changed a little bit because we are in the quadrant where sine is negative. So if we were looking at sine of 240 degrees, sine of 240 degrees, its equivalent reflex angle to be from this point to that point, yes, that's 240 degrees. And the acute angle here is 60 We get 60. Yeah, it is 60 degrees. So meaning that this is not going to be equals to sine 60 degrees because sine in the third quadrant is known to be negative. You have to include the negative at the beginning there. So if you go on your calculator, when you punch 240 degrees, it will give you a value which is negative. But when you punch sine 60, it will give you an answer which is positive because sine 60 is in the first quadrant where all are positive. That's the very reason as to why you need to include the negative here. But for tan, we didn't include the negative because it is in the third quadrant like this. So that's what you need to do. So just establish their acute reflex and their corresponding reference angles. So that's on question number 2. So if we look at 300 sine, the actual value C, which is sine 300 degrees. So sine 300 degrees, this is the exact value for this is, you just have to look for its corresponding reflex acute angle. So 300 is found in the third quadrant. From here to there, it's 90, 180, 270, 360 degrees. All these are degrees. They are all degrees. So 300, you move in an anti-clockwise. So 300 is from that point. See? It is in this quadrant here. In this quadrant, let me just change the page. See, the page is misbehaving. So, so 300 is found in this quadrant. So your movement will be from this point up to this point here. So this entire part is 300 degrees. But this 300 degrees can be replaced by finding this acute from this point up to this, which is your alpha, the acute reference angle. So if from this point to that point is 300, therefore this alpha here is going to be equals to 360 minus 300, which is 60 degrees. So this is going to be sine of 60 degrees, but there's a negative at the beginning because we are in this quadrant where sine is what? Negative. So when you go to your calculator, say sine of 300 degrees is equivalent to negative sine of negative sine of 60 degrees. But this values, negative sine of 60, you can now find the actual values because these are special angles. So negative sine of 60 degrees. This is equals to negative sine 60. You are getting this from the equilateral triangle. Sine 60 is equals to the root of 3 divided by 2. Okay. So therefore, the value of sine 300 degrees is equals to negative the root of 3 over 2. So just first of all, express them to their nearest, express them to the corresponding acute angle. So even on this piece here, you tan 60 degrees is a special angle. So you can find the actual value for this now. Because we not say 60 is a special angle. And what is tan of 60? It's opposite over adjacent. So the opposite of 60 is root of 3. You go, and the adjacent is 1. So the actual value for tan 240 degrees is equals to root of 3 divided by 1. Any question? I think I end here.